We're good? No questions? I don't even know what to ask right now. I'm just waking up. All right. Let's go to 37. And so maybe hold your finger on 37. But what we really started to talk about on Friday, we started to talk about polygons, right? And some of the things, this is on 32, by the way. Some of the things, right, we talked about convex versus concave. We're going to mainly work with convex polygons. We looked at regular versus irregular. You need to make sure these two conditions are met for something to be considered regular. We talked about interior and exterior angles and the property in between them. What they're related by the fact that they're always along a straight angle, so they always add up to 180 degrees. The number of sides tells you how many interior and how many exterior angles there are. We talked about the fact that the exterior angles always add up to 360, so this is going to come in handy later on. If we knew that this was a regular polygon, we could essentially say, well, 360 divided by the number of sides, and then we have our measure of each exterior angle. And that's how we got these formulas. So I hope that you were able to transfer on page 33, you were able to transfer these formulas onto your study sheet. If not, you need to do so for tomorrow. We're gonna have our quiz on, I said Tuesday, I know. I think I'm gonna do Wednesday and then test Friday. You know my frustration with my copying limit, right? So I'm a little stuck right now. Anyways, maybe I have to go to Staples and just print it there myself. But we'll just keep it Wednesday, Friday for now. So these formulas should be on there. We calculated them. We knew where to find ice, like the one interior, exterior, and central. You need to know their location. Then on page 34, I asked you to calculate all of those, use the formulas to calculate all those measurements for this shape here on 34. We kind of expanded that at the bottom of 34, and then I'm just gonna start having, questions where I'm like, solve for those missing angles, and you're supposed to know which formula to use to find them, right? And then on 35, I want to spend I used to make students fill this whole thing out. I find it kind of pointless after a while. What I do want to give you is the prefixes and the number of sides that correspond with it. So this is on page 35. If you could go to 35 and just look this up. So on 35, you have tri, that's 3 sides, triangle. Quadrilateral, that's 4-sided. Those are all polygons. Page 35. Penta, 5. Pentagon. So now we start with the gons, right? After penta, or starting with penta, I should say. Hexa, 6. Hepta, 7. Octa, 8. Nona, 9. Deca, 10. And I don't know, I think they just, when they had this meeting, they disagreed on 11, so they just skipped it. Dodeca is 12. 12-sided. So there could be an instance where I ask you what's the name of this polygon. Like, let's say you calculate that it has 9 sides, then I'd expect you to write down nonagon, right? So the rest, like as you can tell, these ones, right? This is the sum of interior angles, the interior angle, all those. Like you could calculate all of that, but it's just so much work. And I would expect you to, at this point, just be able to calculate that no matter what, right? And we usually have bigger, like more sides than 12 quite often. All right, so so that I didn't fill in on Friday, but now you do. We work backwards on page 36. Let's go to 36. What is backwards? It's basically when you use algebra, you start with your formula and you work backwards to solve for n, to isolate n. So that one, I can guarantee you're going to have this on the quiz and test, a question that asks you to do this. And you can't guess and check. So a lot of students will just plug in a number until they get that sum. That's not good enough, right? So you have to, the point here is to show it algebraically. Okay. The most complicated perhaps is if I give you the interior angle, like if you know the interior angle, then you have to start with this formula and slowly isolate for n. Or you can just say, hey, if I know the interior, I automatically know the exterior. Like automatically, you just have to subtract and then use the exterior angle formula to solve that one. So, okay. Let's go to 37. I'll get you to do a little bit of work here. How many of you, I don't expect you because I didn't assign, anybody do this one already on page 37? Anybody solve this one? Okay, so that's going to be our warm-up today. Regular polygon has interior angles of that. Determine the number of sides. So this is using what we did on the previous page, going backwards. And once you're done that, keep going to 2 and 3 as well. Technically, you're supposed to know how to do those. You have the tools, I should say. You have the tools. Are you supposed to know how to do them? Maybe you'll have to think a little bit about them. So we'll take a few minutes on this. All right, let's see how it went. I actually have no idea what the answer is right now. Two methods, right? That's how you would set it up if you use the traditional interior angle method. You multiply both sides by n. Cancels out. That's 175.2 degrees n. And you distribute here. That's 180 n minus 360. Right, so you got to distribute that like that. I'm going to subtract 180 n from both sides. And that gives me 4.8 here. That'd be negative. And you're left with negative 360 on the other side. You subtract, divide both sides by negative 4.8. This gets canceled out. That's 75 sides. There we go. So that's one method. The other would be to figure out that the exterior angle is 180 minus 175.2, and that's 4.8 degrees. So you set up, right, 4.8 degrees is equal to 360 degrees over n. You put the 1 there, cross multiply and divide. And you get 75 sides as well. Okay, either way works. Nothing wrong with either method. Just show me the work. Show me how you got that, right? Including this line up here, like telling me what the exterior angle is. And there you go. What else can I say here? Yeah, you shouldn't get decimals for your n values. Okay. So there's. All right. It gets tricky because some interior angles have decimals that keep, like, they're not finite. So those I can't really use because you would get a decimal for n, right? So I'm going to use the ones that you get where you get a whole number. Anyways, next, let's tackle this one here. Some of the important terms, as you go through it, you will get bits and pieces here. It's a pentagon has the following interior angles. So all of these are interior angles. Determine the fifth interior angle. Right? So there's obviously, if it's a pentagon, n is equal to 5 sides. Right? So there's 5 interior, 5 exterior, and 5 centrals. Okay, we know that just by us knowing that it's a pentagon, we know that there's 5 of everything. So we want the fifth interior angle. So for A, we will first find out the sum of a 5-sided pentagon. We're not told it's regular or irregular. However, upon examination, can we tell whether this is regular or irregular? Just look at the angles. They're supposed to all be the same. So we know this is not a regular polygon there. So some of the things, I'm just throwing them out there. So sum of a 5-sided shape would be 5 minus 2 times 180. That's 3 times 180. That's 540. So first you want to know, well, what's the sum supposed to be? It turns out that it's 540. No matter what, if it's regular or irregular, it doesn't matter. Okay, so that's the sum of all, right? So the last interior angle will be found by just going 540 minus all of the angles that are there. You can either add them up, and then subtract it from the total. Whatever you want to do is fine. Okay. And I'm just gonna do this real quick. $134 is my last one. Is the fifth interior angle. Okay. Determine the value of each exterior angle. This is a little annoying. I'm going to make a table. Okay. I'm going to say, like, these are my interior angles here, and my exterior angles are going to be right underneath it. So there's 5, right? So 1, 2, 3, 4, 5. So what I'm going to do is I'm going to list my interior angles here. I'm going to go 100, 102, 99, 105, and the last one that I found is 134. So we know that every interior angle will have its exterior angle right next to it, correct? So they always add up to 180. So I'm just going to subtract what I have from 180. So I'm going to use a different color just for notes here. Right? This is 80. This is 78. This is 81. This is 75. And this is 46. Okay. Add up to 180 degrees, right? Maybe if you just zoom into any one of these angles, so let's say the very first one, you have the 100 here. This is 100. And so if you made the extension here, you would get the 80. Yeah. And obviously this polygon, it's not regular, so we don't really know exactly. We could probably do it with a protractor. and measure it exactly and go for it, but we won't. So this is B, sorry, that's B, what I just did there. So yeah, sometimes if you want to organize it using some kind of table, absolutely fine with me. C, is this a regular or irregular polygon? Explain. It is irregular, since all angles. Okay, this can be said in multiple ways. Because if every single angle would be the same except for one, it still would not be regular. Okay, so you can either say it's irregular since not all interior angles are congruent. So maybe I will say that. It's probably better since not all interior angles are congruent. We don't know anything about the side lengths, but we don't need to. It fails already without knowing that extra piece of information. All right, next. How would you solve that one? Solving for x. Here we go. Any brave volunteer, how would you even start something like this? Anyone? If you get it wrong, there'll be 0 repercussions, right? It won't even hurt you one bit. You know, okay, let's put it this way. If you had this in a triangle, bunch of x plus somethings in a triangle, what would all those angles add up to? 180, right? This is not a triangle, it's something. But we can find what the sum is supposed to be, right? Triangle we just memorized, but just look at number of sides, right? So count 1, 2, 3, 4, 5, 6. 6 sides. So again, what can you know in this case? What can you find out? You can find out the sum of a 6-sided shape. That's 6 minus 2 times 180. I'm just using the formula S, right? That's 4 times 180. That's 720 degrees, right? Important, but not the final answer, right? Sum of all what? Interior angles. That's what you found there. That's your. So that's one thing about polygons, guys. It seems that you don't have enough information, but you actually have. You just need to count the number of sides. Bingo, you've got a lot of information there. So how you want to do this, up to you. I'm going to say that 720 is supposed to be equal to, it's going to be a bit tedious here, x plus 40 plus, I'm going to start with this angle here, okay? And then it's x plus 60. Yikes, is this going to fit in? I will make it work. It's not going to work. Sorry, I'm going to redo it. I'm going to start further down because it's just going to be all squished in there. Do it again. 720 is equal to x plus 40 plus x plus 60. And these expressions could be, 2x plus 80. It could really vary greatly. And there's just an x here, and then there's an x plus 20. So just go ahead and set it up like that. Everything is adding here. You don't have a single negative, so you don't really have to worry about the brackets, really. I'm just going to maybe see how many x's I have here. These 6 of them. Okay, so I'm going to go 720 is equal to 6x, and I'm also going to at the same time figure out how many constants I need to add up there. This is 60 and 40 is 100, 180, 280 plus the 20, that's 300. So that whole expression just boils down to that. When you have multiplication and addition or subtraction, I would first deal with that. So we go minus 300, that's 320, is equal to 6x. Now you divide both sides by 6, and you've got everything you need. Okay. That's 53.33. Yeah, 53.33 degrees. That's all right. It's degrees. It can happen. Yeah. Didn't make a mistake. Thank you. I was just going to say, be careful on Monday morning. Don't copy everything right away. Okay, thank you guys. So that's 70 then, right? But don't be scared of decimals, but this is obviously my mistake here. Thank you. All right. We got it. Thank you guys. Thank you, Liam, for having the courage. So that's how you do something like this. I'm going to tell you this. There's no cookie cutter approach, like this is how it's always going to be, but I want you to start thinking, what can I find out, right? When I'm stuck, like what can I do, right? Find things, right? Okay, let's keep going here. The homework still stands. I assigned these questions 38 to 41. Maybe I'll ask you, is there anything you need me to do here to clarify? And if you don't know, because you didn't do it, make sure you do it, right? Make sure you give us a go because it's going to be important for you down the road. Maybe I'll give you a little bit of time here on page 41E. 41, bottom of 41. If you did it already, that means you did your homework. So you can just sit back and relax a little bit. If you still need to do it, take a little bit of time right now. Maybe just, I won't give you time to solve the whole thing, but at least to get your brain engaged in something like this. Would you be able to solve that based on what I just did here? So look at 41E for now, and then I'm gonna start inscribed polygons next. So I'll give you a couple minutes here to take a break from me, right? So there we go.